Okay, Calculus, Grade 12, First Principles and Differentiation Rules, November 2021, Grade 12 exam question. This question is from paper 1, from question 9, from DBE. Okay, this is the question 9. You have 2 questions, and on 9.2, you have 2 sub-questions. Okay, let's get started. 9.1, determine the first derivative of x, or determine f prime of x from first principles if it is given that f of x is equal to 2x squared minus 3x. This question is 5 marks. Okay, so you are requested to use the first principles. If you use the rules of differentiation, this is what you are going to get. F prime of x is equal to, you have the exponent is 2 and the coefficient is 2. So you have 2 times 2, it's 4. X to the power of 2 minus 1. You subtract 1 from the exponent. Okay, you are going to have x to the power of 1 when you subtract 1 from the exponent. Okay, so you end up with 4x, x to the power of 1. You carry on, you have minus 3x. The exponent is 1. You have an invisible exponent of 1 and the coefficient is negative 3. Okay, 1 times negative 3, this is negative 3. Okay, 1 times negative 3, this is negative 3, times x, x to the power of 1 minus 1. You subtract 1 from the exponent. Okay, so you have x to the power of 1 minus 1, which is x to the power of 0. Anything to the power of 0 is 1. So you have 1 times negative 3, you end up with this. Okay, so f prime of x is equal to 4x minus 3. Okay, you get this using the rules of differentiation. Okay, but the question says determine f prime of x from first principles. Okay, using first principles, you expect to get the same answer as this. You have to get this as your answer, even if you use the first principles. Okay, now let's answer the question. Whenever they say use the first principles, they want you to use this formula. Okay, this is the formula they want you to use. Whether they say use the first principles or use the definition, they want you to use this formula. Remember, you always have negative day. You are going to have negative day always, because the formula is dealing with change in. This is the reason why you have negative day. Okay, let's carry on. Okay, this is equal to the limit as h goes to 0. Okay, or as h approaches 0. Okay, now you have f of x plus h, right? F of x plus h, and then you have minus f of x. You start with this, you have x plus h. You are going to remove x. Whenever you see x, you remove x, you put x plus h. Okay, so you are going to remove this x, you put x plus h. You remove this x, you put x plus h. And then this is what you get. Instead of x squared, you have x plus h squared. Instead of x, you have x plus h. Okay, and you still have your negative, this negative. Can you see this negative in front of 3, right? You have the negative in front of 3, and everything is in square bracket so that you don't confuse. Okay, let's carry on. Now you have this. You have your negative day. This negative. Now you are going to use x, this x. After using x plus h, you are going to use x. Whenever you see x in there, you substitute x. Okay, you take this x, you put in there, you end up with the same thing. Can you see? When you substitute x in there, you end up with the same thing. Okay, so this is what you get. You close everything inside the square bracket. This is over h, right? You carry on. This is equal to the limit as h goes to 0. Okay, you have your square bracket. You have 2. You have this bracket. Let's expand this bracket. Okay, you have x plus h square. Let's expand the bracket. So you have x to the power of 2. This is x squared. you have x times h. This is xh times 2, you have plus 2xh. So you have plus 2xh. You carry on, you have plus h to the power of 2, you have plus h squared. Right? You close your bracket. You have this. Okay. You close your square bracket. Minus. You have this. Okay. Over h. Okay. Let's carry on. This is equal to the limit as h goes to 0. Now you have 2 times x squared. You have 2x squared. You have 2 times this. You have plus 4xh. You have 2 times this. You have plus 2h squared. Okay. Negative 3x. Negative 3h. Okay. Everything inside of the bracket change the sign because of the negative in front of the bracket. So you have negative 3x and then negative 3h, right? You carry on, you have negative in front of the bracket. Everything inside of the bracket change the sign. You're going to have negative 2x squared. And then you have plus, because of the negative there, you have plus 3x. Okay, over h, right? Now you can see 2x squared minus 2x squared. This is 0. So this goes. You have negative 3x plus 3x. This is 0. So you remain with 4xh plus 2h squared minus 3h. You can see you have h in there, and you have h in there, and you have h in there. You can take h outside of the bracket. Okay, so you can factorize h outside of the bracket so that you can have cancellation with the h in the denominator. Okay, so let's carry on. You have the limit as h goes to 0. Take h outside of the bracket. When you take h outside of the bracket, you remain with 4x. You take h outside of the bracket, you remain with plus 2h because you have 2h squared. When you take h outside of the bracket, you remain with 2h. Okay, you take h outside of the bracket, you have negative 3 remaining. You close the bracket. This is over h. Now you can see this h and this h can cancel. Okay, so you have this. Now you carry on. This is equal to, you can see now you can substitute 0 for h. Whenever you substitute 0 for h, you are going to drop this. Do not write this. Whenever you substitute 0 for h, this is the only time you are going to drop this. Whenever you substitute 0 for h. Okay, let's do that. You are going to put 0 whenever you see h. Okay, so you have 4x plus 2h. You substitute 0 for h, so you are going to have plus 2 times 0 because h is substituted with 0. Okay, so you have this minus 3. You can see I did not write this, right? I don't have this part because I have substituted 0 for h. I have to drop this. Okay, so this is the only time you are going to drop this. Whenever you substitute 0 for h, drop this part. You can see I don't have it. Okay, so you have, this is equal to 4x minus 3. Okay, so this is 0. You end up with 4x minus 3. You can see this is the same answer. Okay, now question 9.2 and 9.2.1. Determine 9.2.1. Determine the derivative of y with respect to x if y is equal to this. The question is 3 marks. Okay, you are given y is equal to this. Okay, this is what you are given. You can see. So the derivative of y with respect to x, this is equal to, the exponent is 5 and the coefficient is 4. Okay, 5 times 4, it's 20 times x. to the power of 5 minus 1. Okay, x to the power of 5 minus 1. You subtract 1 from the exponent. You have now 4. Okay, after you subtract 1 from the exponent, you have this. So you have 20x to the power of 4. Let's carry on. The coefficient is negative 6 and the exponent is 4. Okay, the exponent is 4 and the coefficient is negative 6. 4 times negative 6, this is negative 24. Okay, times x to the power of 4 minus 1. You subtract 1 from the exponent, you have x cubed. Negative 24x cubed. Okay, let's carry on. The coefficient is 3 and the exponent is 1. Okay, there is an invisible 1. So the exponent is 1 and the coefficient is 3. So you have 1 times 3, which is plus 3. Okay, 1 times 3, which is plus 3, times x to the power of 1 minus 1. You subtract 1 from the exponent. So you have x to the power of 1 minus 1. You subtract 1 from the exponent. You have x to the power of 1 minus 1, which is x to the power of 0. And anything to the power of 0 is 1. So you have 1 times 3, which is 3. So the final answer is this. So this is the answer to question 9.2.1. Now 9.2.2. This is the question. Determine the derivative with respect to x. Okay, so this is what you are given. Right? The question is 4 marks. Determine the derivative with respect to x. Okay, so before we can take the derivative, you need to do some rearrangement. You need to rearrange this so that it can be easy for you to determine the derivative. You cannot determine the derivative easily when it is written like this. So we are going to get rid of the cube root sign and we are going to raise this to the power of 2. Okay, so before we can take the derivative, we need to get rid of this so that it can be easy for us to determine the derivative. Let's do that. Okay, so you have this is equal to, let's get rid of this. You have negative there, right? Let's get rid of this. How can you get rid of this? Let me show you how you can get rid of this. Okay, for example, if you are given this and you have to get rid of this fifth root, you have the fifth root of x cubed. This is equal to x to the power of 3 over 5. So you have now the fraction x to the power of 3 over 5 like this. X to the power of 3 over 5. The 5 is from there. Can you see this 5? Now the 5 is the denominator of this fraction. This exponent is a fraction. Okay, so this is how you can get rid of the root sign. Fifth root or square root or cube root or fourth root. Any root. Okay, let's see another example and we can get back to the question. For example, if you are given this is the square root of x, right? Square root of x. This is equal to, remember there is a 2 there. There is an invisible 2. Okay, and x is to the power of 1. So if you have to get rid of this, you are going to say x to the power of 1 over 2. The 2 is from there. Just like in the previous example, the 5 is from there and this 2 is from there. The exponent is 1, right? The exponent is 3. Now let's get back to the question. You have the cube root of x. To get rid of this, you are going to have x to the power of, the exponent is 1. So you are going to have x to the power of 1 over 3, right? This is over 2 plus you have 1 to the power of 2, still 1 over 3x to the power of 2. This is 9x squared, right? Okay, and another thing that you have to do is to get the variable in the numerator, right? Get the variable in the numerator. Always get the variable from the denominator to the numerator. Okay, so this is what you are going to get. You have this plus, now you have this x squared. You take it from the denominator to the numerator, the sign of the exponent change. Okay, so it's positive, now it becomes negative. If it was negative, it's going to be positive. Now you can see it is positive, it's going to change to negative. So you're going to have x to the power of negative 2. Okay, from positive to negative. Okay, so this is times 1. You still have this over 9. You only remain with 9. You still have your square bracket there. Now, this is simple for you to take the derivative. Okay, so this is equal to, when taking the derivative, we are going to drop this. do not write this. When you start taking the derivative, do not write this. Okay, so this is equal to, it's negative, you have this over 2, you have x to the power of 1 over 3. This is your exponent and the coefficient is 1. There is an invisible 1 there. So you have 1 over 3 times 1. This is 1 over 3, right? 1 over 3 times 1. This is 1 over 3. X to the power of, you subtract 1 from the exponent as we did in the previous question, even in this example. Okay, so you subtract 1 from the exponent. You're going to have x to the power of negative 2 over 3. Okay, you can check it. Let's carry on. Plus, you have this over 9. The coefficient is 1 and the exponent is negative 2. Okay, negative 2 times the coefficient, which is 1, right? Negative 2 times 1, this is negative 2. X to the power of negative 2 minus 1. You subtract 1 from the exponent. You are going to have x to the power of negative 3. This is equal to, you can see you have negative there, and you have 1 over 3 over 2, right? 1 over 3 over 2. This is 1 over 6. X to the power of negative 2 over 3. Negative 2 over 3. You have plus times negative. Plus times negative. This is negative. You have 2 over 9. X to the power of negative 3. So this can be your answer, or you can get your exponent to be positive. Instead of negative, you can get your exponent to be positive. Okay, so you can say this is equal to, you have negative there, 1 over 6 x to the power of 2 over 3. Instead of a negative exponent, you have a positive exponent, and then you have negative 2 over 9x cubed. You change this from the numerator to the denominator, the sign of the exponent change from negative to positive. You change this from the numerator to the denominator, the sign of the exponent change from negative to positive. Okay, we are done with question 9 from November 2021 from DBE. Until next time, I will talk to you soon.